We're on the internet all the time, right? But have you ever really stopped to think about where it is? Like physically? I'm not talking about some abstract idea. I mean, where are the actual buildings, the secret headquarters that make our whole digital lives possible?
No, really, think about it for a sec. You stream a movie, you send an email. Where does that stuff go? It has to exist somewhere in a real place, doesn't it?
And here's a hint for you. It's not in a cloud. Yeah, that whole cloud thing we all talk about, it's kind of misleading. The internet doesn't live up in the sky. It lives in these massive, super powerful buildings, right here on the ground. So today, we're going to pull back that curtain. We're going to find out where the internet's real home is, how we power the whole thing, how we run all the games online, and maybe most importantly, we'll look at your path to actually mastering this incredible field. All right, section 1, the internet's real home. Now, to really get this, let's use an analogy that I think pretty much everyone can get behind. A giant, high-tech video game arcade. Just imagine an arcade, but for the entire internet. Okay, so let's break this down. A data center? It's a real building, usually the size of a huge warehouse. But instead of arcade cabinets, it's packed with rows and rows, thousands of super powerful computers we call servers. And the players in this arcade? Well, that's us, internet users. And that big, central high-score server that keeps track of everything? That's your cloud services, your Netflix, your TikTok, your Gmail, all of it. So who runs these places? They're called Datacenter Systems Engineers. And listen, these aren't people just coding one little app. No way. They are the master architects, the engineers, the managers of the entire arcade, making sure millions of games are running perfectly, all day, every day.
Which brings us to section 2. Because powering this arcade means solving some of the hardest questions in engineering. I mean, we are talking about absolutely massive challenges.
Like this one. How in the world do you stop a million high-performance computers from literally melting through the floor? And I'm not talking about your laptop getting a bit warm here. We're talking about warehouses packed with servers, kicking out so much heat they could cause a literal meltdown if things aren't managed perfectly. The answer comes down to two huge things: power and cooling systems. For power, these engineers are basically building their own industrial-grade electrical grids. Get this. A single large data center can suck up as much electricity as a small city. It's wild. That's why they have these giant backup batteries called UPS for any split-second power flickers. And then they have bus-sized diesel generators on standby just in case. And for cooling? Oh man, it's this super precise science of airflow. They design these hot aisles and cold aisles to perfectly manage the heat. So let's go back to our arcade. This is like being the person who makes sure every single machine gets the perfect amount of power. It's like putting a little fan on each one so it doesn't catch fire. And it's like hooking up the whole building to backup generators so that even if the whole city goes dark, the games never, ever stop.
Okay, so that's the physical building. Now let's talk about the magic inside the machines. Section 3, running the games. This is all about the software that makes everything tick.
Think about it. It would be crazy inefficient to have one giant server for just one website, right? So how do they solve that? How do you make one machine run like 100 different games all at once?
The answer is something called virtualization. And this is the real secret sauce. It's a software trick that lets one super powerful physical server act like it's 100 separate smaller servers. This idea, right here, is the technology that makes the cloud possible. Back to our arcade analogy, virtualization is like figuring out how to make one giant arcade cabinet run 100 different classic games all at once. And on top of that, you've got to lay down these crazy fast cables that connect every machine to that central high-score server so there's absolutely zero lag. So, what if this sounds cool to you? What if you want to be one of these master architects for the internet? Well, here's the good news. There's a clear path to get there. Your adventure can start right now.
Basically, you can think of your journey in 3 phases. First, you build a solid foundation in high school. Then, you get an undergraduate degree. And finally, you can do a master's degree to really specialize and learn how to do all this at a massive, massive scale.
And maybe the most important piece of advice, the absolute best way to start, is to build a gaming PC. I'm totally serious. A modern gaming rig is like a tiny data center. You have to think about power, cooling, networking, all the parts working together. It teaches you all the core concepts on a small scale that's actually fun.
So, let's talk phase 1, your high school foundation. You're going to want to focus on physics and math. And yeah, build that PC. Also, start learning some basic Python. It's huge for automation in this world. You can even start to understand networking just by messing around with your home Wi-Fi router.
All right, for your undergraduate degree, you've got some great options. Computer or electrical engineering if you're into hardware, mechanical engineering if those cooling systems sound awesome, or computer science for the software side of things. And here's a pro tip, whatever you choose, try your best to get an internship. That real-world experience is absolutely priceless.
And that brings us to Phase 3, diving deep with a master's degree. This is where you really connect all the dots. It's where you go from understanding one server rack to understanding how to run a whole data center that's the size of a city.
Because when it comes right down to it, it's all about this one thing. 24/7. That is the required uptime. The systems have to work all the time. The work these engineers do is literally what keeps our entire digital world from going dark. The stakes? They just don't get any higher.
It's this huge, incredible job that's part hardware, part software, and all high-stakes problem solving. So the only real question left is, are you ready to build our digital world?